Let us start the program. Very good morning, all. I am Dr. Jamshila. Today, I am very glad to present before you a wonderful resource person, Dr. Muhammad Abdul Hamid sir, for this webinar. He is presently working as Assistant Professor, Department of Computer Science and Engineering, University College of Engineering, Osmania University, Hyderabad, besides being a visiting faculty in many premier institutions. He has many published works in data mining in reputed publications. As you all know, big data has been a topic widely discussed in Kerala political circles and TV channels recently when Sprinkler scam allegation was raised. Data is considered to be a treasure these days by the corporates. It is a priceless information for many purposes. Recently, WhatsApp also has been accused for passing personal data of its users to Facebook. Hadoop is a widely used platform for managing big data. Today, our topic for the webinar is big data using Hadoop. Now, let me pass on to the duty of welcoming all. First of all, I would like to extend a warm welcome to our resource person, Dr. Muhammad Abdul Hamid sir, to this webinar. Welcome you, sir. I am
Thank you.
happy to welcome our beloved principal, Dr. Ayub K. sir, to this webinar, who is a great supporter of this program. He will inaugurate the webinar. A warm welcome you, sir. HOD Riyad sir will preside over the program. Hearty welcome you, sir. I also extend a warm welcome to all my colleagues, my dear students, friends, and all the participants to the webinar, and hope it will be a very interesting and informative session to all. I request Riyad sir, HOD Riyad sir, to preside over the webinar. Thank you. Thank you all.
Okay, thank you. Respected Principal Dr. Ayub K, our honorable guest and the resource person of this webinar, Dr. Muhammad Abdul Hamid, Assistant Professor, Department of Computer Science and Engineering, Osmania University, Hyderabad, coordinator of the webinar, Dr. Jamshila, faculties of the college, and various other organizations, and dear students. It is a great pleasure to have a prominent faculty from Osmania University as a resource person for this webinar, and I congratulate the coordinator of the webinar, Dr. Jamshila, for arranging the same. We all know that the topic discussing here on big data is highly trending one, and data is useless if there is no skill to analyze it. So big data analytics helps to identify opportunities in various aspects of the business, especially in sales and marketing, which necessitates the implementation of big data tools like Hadoop as a key factor for decision making. It gives more precise business insights. We all know that there is a huge deficit in the skilled talents, especially data scientists, for data analytics to be filled in the worldwide, largely in unstructured and structured analytics. This has led for highly paid various job titles in this domain. All this leads to an excellent opportunity for the aspiring students to indulge in big data analytics, and I am sure this will be a rare opportunity for the attendees of this webinar to make use of this as a stepping stone to this highly promising field and build their career from here. So without prolonging, let me invite our beloved, ever supportive principal, Dr. Ayub K, for his inaugural address. Thank you very much. So Ayub sir, you can uh, start your speech, sir. I invite our principal, Ayub sir, for the inaugural function. Thank you.
Am I audible?
Yes, sir, you are audible. Please,
Yes,
please
sir.
proceed, sir.
Hello? Hello?
Yes, sir.
Yeah, good morning all, good morning all. So, sorry for the delay. There was a technical issue here. Sorry for the delay. So, respected the chief guest of the day and the resource person, Dr. Mohammed Abdullah Hamid, Osmania University, and the head of the Department of Computer Science, Mr. Riyadh, and the coordinator of this webinar, Dr. Jamshila, and other faculties of the department and the students of computer science and other computer science department of this college and other colleges. So good morning all and greetings from EMEA College of Arts and Science, Kondoti. So I'm really appreciate and really happy to know that the Department of Computer Science is organizing a series of webinars related to these topics. And they understand and they realized that the classroom teaching and learning is not sufficient for our students because this is the field, the computer science and information technology field is the field where the update is taken place every day, every now and then. So they have everyone which are who are related to the computer science and information technology have to be updated to sustain in the field and to sustain in the job market. So it is a good attempt from the computer science department to organize the series of such type of webinars which are very much important and which are helpful to our students. And I request all the students to explore and exploit the webinars which are conducted by the computer science department for the last 2 months. They have conducted. This is the third one. They have conducted so many webinars and other activities. So I am thankful to the resource person and I'm really appreciate the department for conducting such type of webinars and wishing you all the very best. And with these words, I inaugurate this webinar. Thank you. Thank you very much. Over to Riyadh sir.
Thank you, sir.
Okay, I now cordially invite our chief guest to take over the session. So please take over this session. Thank you very much.
Good morning, everyone. Thank you for this invitation. And Dr. Jamshila, please start sharing the screen because some problem is from this side. So because you are also host, the PPT what I sent you, kindly share it.
Okay, sir. Now you are host. I have changed you.
Okay. Some problem from this side.
Yes. Sir, now you are the host.
Yeah, I'm looking. Is the screen visible now?
Yes, yes. Yes, doctor.
Thank you. It is good morning, everyone. It is glad that I had an invitation from your college, esteemed college from Kerala, and I really feel very happy to address the people of Kerala. The special reason for this is I always have a lot of regard and respect for Keralites, and the very reason for this is like when I was in high school, I was having a very good teacher to whom I really used to admire, and really I was very obedient to her. And she was Kerlite. So this is how I feel some relation between me and Kerlites. So coming to our today's topic, big data introduction with Hadoop. Before we switch directly, what is big data? Let us come from the background, like how the data issue started. Like in the very early stages, there was a situation where people used to exchange goods, like barter system. People used one who used to cultivate rice. He used to offer rice to the person who used to cultivate dal, and the one who used to cultivate some vegetables, he used to give him rice and take some vegetables from him. It was a barter system, and life was cool. There was no issue of storing, there was no issue of recording, there was no issue of logs, there was no issue of databases at all. But somehow, after certain duration, the status has changed, where people started their financial transactions. The moment they started financial transactions for all these things, business things, they started doing all transaction by means of finance. In that particular situation, they started exchanging. They started offering some price for every item and used to purchase things. And when they used to purchase things, they started putting record, like what record of their repository and record of what they have sold today. They used to maintain some logs, and if the shop is small, then the log used then like small log used to run for almost a month. But if the shop is big, something like today's supermarket, then even 200 pages log is not sufficient in a day, and they cannot depend on manual writing of logs. Gradually, they updated themselves to databases, and even the databases were falling short. Then the technology has grown to such a level that now the data is being stored in data warehouses as well. And we know what is the difference between normal databases, OLTP, and the data warehouse, OLAP. I'll not go in detail of that, but somehow, if anybody is interested, they can just see the difference between OLAP and OLTP. Here, as the database's capacity went on increasing, meantime, data also um, went on increasing, and the data was being stored in data warehouse, databases, in day-to-day life. Huge data was collected. In that particular situation, there should it was realized that there should be some technique that this data to be utilized for the benefit. Like for example, I would like to mention you, like people are making gases from the waste. I was just watching one short clip on WhatsApp where a person took the waste of elephants and started making paper out of it. Just imagine, people are the thinking of the people have become so optimal that they don't want to waste anything, but they want even to use the waste for the benefit of the humanity. So in that particular situation, when every person want to make best use of whatever he has in his surroundings, then we, being the data scientist, it is our duty, it is our responsibility that we make best use of this data. And the time has come, when the data is in huge quantity, volume, and at the same time, data scientists are being looked with an expectation. When data scientists, the world is looking at the data scientists and community with some expectation that this huge data is available now. what should be done so that some beneficial points can be retrieved from the existing data. In that struggle, in that um, uh, with that motivation, few subjects have evolved in past 10 years, in past 20 years, like data mining. There are so many data mining techniques. Then machine learning has come, then deep learning has come. But one thing which is very common in these three, that they work on well structured data sets. But apart from these three, there is one more dynamic domain of data science, that is nothing but big data. And the very speciality and very different aspect of big data is it is purely based on the unstructured and semi-structured data. In a way, we can say that whatever we find on World Wide Web, it's a mixture of structured tables as well as unstructured emails and text, and semi-structured documents mixed with some tabular forms and normal text. All these things have evolved. So there was a need and necessity of big data as well. And when and it is listed that when we start making use of this data, mainly it should benefit the human beings in a way that in a way that what is the behavior it should we should, because we have historical data. I would like to make clear one aspect. What is historical data? Because unless we understand the term historical data, it is not easy for us to understand the remaining part, or understand the significance of big data, or understand the significance of the use of the voluminous data what we have today. Like take for example, you are visiting a supermarket since 5 years, or not only 5 years. 5 years is a very long. You can say since 1 year you are regularly visiting a supermarket. Do you think that when you go and when you enter the supermarket, can the salesman make a prediction? Can a salesman analyze for what goods you have come today? Like, for example, based on his past data of 1 year records, whatever he have purchased, 1 year past data, or which is termed as historical data of the user or the customer, we can predict what he will purchase when he come in the first week of the month. If he comes in the second week of the month, what he will purchase in the third and in the fourth. We can predict that if he have come in the first month, what may be his total bill. Second week, third week, fourth week. No doubt this example is very small example I have given only for you to understand what is historical data. And based on the historical data, something to understand is we can make predictions, we can assess our customer based on his past purchasing behavior. This is something what is very important, and this is something for what this entire big data analytics or data mining, machine learning, deep learning, all these fundas are going on. It is to understand the behavior of the user. It is to understand the behavior of the customer. It is to understand the behavior of the market as well. It is to understand what is the trend being adapted in the market. In a way, it is something to understand what is happening today, as well as based on past and current, what is going to happen tomorrow as well. So in a way, this will the existing data will help us in understanding the behavior of our customer, as well as it will help us to make prediction how will the customer behave tomorrow. And based on the prediction how he will behave, we have to get ready to fulfill his requirements in our mall. This is something, the reason why we study this data science related issues. Now, if we look in detail, the data is increasing day by day. The data is increasing, and we can see how the data is increasing, or how the data is being formed here. Like the units of data is being listed here, starting from byte, kilobyte, megabyte, and so on. You can see the numbers, and you can just check how huge the units are as we go further, lower and lower. What is big data? See how the data is getting collected in huge and voluminous level. Here I have kept few images. First image is something like, in all government sectors, there are so many files. The whole hard copies are being converted to soft copies. Like, you can see the files. For example, there are so many files in government organizations which cannot be ignored, which cannot be just kept aside, which cannot be left without attention. Like, for example, there is a office what we call as registration office, land and all registrations and notaries, whatever they do. So um, years together data is being stored in file in hard copies. But as the software, as the automation is taking control, as everything is being automated, these files are also being scanned and made available online, so that whenever anyone want to check whether to purchase this land or not, he has full data, and he can make decision based on the available data. Likewise, all departments of the government which are holding centuries of data, literally speaking, century of more than 1 century of data also, that government has, and that to be automated, that to be converted into software, soft copy, and that to be available on the web or in the repository whenever they want, they can refer it. This is how the data is increasing in one way. And another way is the social media. Here I have listed 500 plus terabytes per day. But remember, this slide is made long back. So when I was making almost like 5 years back, this data was available on the net. So social media does not mean only Facebook. We have so many. WhatsApp is there, Facebook is there, then at the same time Twitter is there, LinkedIn is there, and now even the Signal is coming up gradually. So all these social medias are being pumped with huge data from every user across the globe. They are pumping a lot of data on the web. That is one of the source. And aeroplanes, the planes which travel from one point to another point, we just go and board it and get down after our journey, after it reaches to the destination. But to our not, we should be knowing that these aeroplanes, these engines are having so many sensors which will be communicating with one and another, and they are so much well automated that based on the communication between the sensors, they also manage things. And by in all these operations, even these generate terabytes of data, petabytes of data per day. So likewise, stock exchange markets are there. Later, if you see in the last, the electrical grid situation is there. Like, simple example, electricity is produced in one plant, electric generation plant, but that from there it is supplied to cities, from there it is supplied to localities, from there it is supplied to the residents. And in residential areas, again, in every residence, again it is being supplied to like in a endpoint, it is glowing some bulb or tube light or generators or some electric stoves or so many ACs, whatever. But all this supply chain should be monitored. How much electricity is being generated, in which directions that is being supplied, and at which end what is being glow, and how much electricity each point is being consumed. And this job is not a simple job, and all this data is being stored. All this data is being stored so that they can improve their performance by analyzing this data in future. So this is how, from every corner of the world, from every department, from every individual, in fact, the data is being pumped on the World Wide Web. So uh, these are the reasons how the data is being increasing day to day. But at the same time, some huge problems are also associated with big data. The very huge problem is unstructuredness. The data is unstructured. Somebody is uploading image, somebody is uploading text, somebody is uploading audio, somebody is uploading video, somebody is uploading XYZ. So much types of data, so much huge and voluminous data is being pumped. Every individual is posting some or other thing every with a short interval, and that whole data is unstructured. Let me tell you a small example so that you understand what is unstructured actually. Like in normal databases, we can see that it's in a tabular form, right? The data is in a tabular form. There are some attributes, and under those attributes, so many records are there. And all records are well arranged. So that well arranged is nothing but well structured data. But when there is no well structured, well arrangement, then that data which is just arranged, which is just posted over and not arranged properly, that data is unstructured data. And obviously, something which is unstructured, it is also unprocessed, unaggregated, unfiltered, and repetitive, low quality, and generally messy, right? These are the major problems associated with big data. And unstructured data is exploding. Let me explain this diagram. Initially, we can see that the data was only related with relational. Some transaction, some business transaction data was there. But gradually from 1995 and on, the data, complex and unstructured data, is also gradually increasing. The reason why it is increasing from 1995 is World Wide Web started from 1995 and 96. The popularity of that, the general people started using it. Earlier, people used to just feel World Wide Web is only for emails or some small transactions. But later, it is as the days went on, the developers, the software engineers have started making some applications, and those applications have really gave a new turn to the web and digital universe. Like Facebook started from awkward. Facebook, WhatsApp, the whole social media came to image, and so many other online shopping portals, and almost everything is being automated now. And most of them, whatever is getting automated, most of them are being brought and kept open to the world. The the growth of web, the growth of web have increased so much that earlier we used to say universe, the term only universe was being used, where we physically stay. But now the new word has coined like a digital universe, because the physically where we stay we call universe, but digitally we are available in a place where we do almost everything. Here we play, they will do online playing. Here we do banking, they will do online banking. Here we do shopping, they will do online shopping. Here law department, law and justice department is there. Their cyber law department is there. Governance, e-governance, commerce, e-commerce. Everything is being performed performed digitally in such a level that where we are calling one side as universe, the other side we are saying digital universe. So the whole image of the digitalization have turned to a level where we started calling as a digital universe, and this is how the data is exploding and going on increasing, increasing, and increasing. Let me tell you some basic things of big data. Earlier, when we used to talk about big data, we used to just focus on three V's. That is volume, velocity, and variety. Volume is something like huge volumes of data is available. Now, I need not explain what is volume, because in entire previous talk, I was just emphasizing data is increasing, and we have voluminous data. So now the term volume is very clear. Another point, velocity. As I was discussing, that every individual of the user of the social media, or every individual who is using any application or any digital functions, they are posting some or other things on the web. So entry of data on web is very fast. Lot of data is being pumped on the web in a very high speed, and that is compared with the term as velocity. And variety, as I mentioned, somebody is posting image, somebody is posting video, somebody is posting audio, somebody is posting text. Likewise, everyone, whatever he has and he wish to post, he is free. So lot of variety of data is also being sent on the web. Then value, as we know that whole information existing on the web is back at the back end, it is being converted in the form of binary, which is either 0 or 1. So that is nothing but value. And the veracity, how much reliable the data is, because most of the researchers, they started taking data directly from the web, and performing very important and useful, valuable experimentations, and coming out with beneficial findings. But these findings will be reliable, trustable, genuine, unless the data they have picked for their experimentation should really be worthy and should really be genuine or correct in a way, whether the data pumped by a bot or a human. If it is if it is mixed with bot and human, then that data outcomes cannot be reliable or genuine. Likewise, the researchers need to classify bot data to be excluded from the human posted data, and then perform experiments. Then the results are genuine and useful to the market. And finally, when we reached up to 2017, first the V's were like in 2001, the V's were only three V's. In 2012, it went up to 5, 6, then 13, 7, 14. Likewise, gradually number of V's went on increasing. And now in earlier in 2017, it was 42. And these are the list of those 42 V's. I cannot go on explaining each V because we don't have so much time. And anyway, you can refer it. The PPT is submitted to the organizer. You can refer it. By now, in 2021, number of V's are almost 100 V's. So anyway, V's are increasing, and as well data is also increasing. Here just everything in one slide: volume, then velocity, variety, so many things. And these are some of the applications. Earlier, it was only, earlier we used to use the computers for basic requirements like maintaining our organizations, organizational data, and employee data, student data, or customer data, whatever. Then we started using the machines for some better uh, applications like Web 2.0, the second generation of web, where social media was also part of it, but in a very initial level. Then again, we came to a situation of big data, where every action or every movement of every customer is being stored or saved, and based on that, we are performing so many experiments like social sentiment analysis is there, recommender systems are working, then again um, weather forecasting, text imaging, then click streams, blog analysis, all this data is being used. And as you all know that whatsapp uh, WhatsApp have mentioned that they want to share the data with the Facebook. The reason behind that is to understand their users in a more better and in a more clear and in a more specific level. Why? Because if they understand their users, so tomorrow when they understand each and every user in a very specific level, then they can personalize the ads they are presenting. This is only one aspect, but they can personalize the ads based on the requirement and multiply their business gains. The more specific, the more genuine, the more original, or the more touching the ads are, obviously there is a growth in business. So to understand perfectly, the more the data, the more better understanding is. Like two friends are there. In first meeting, they look at each other and keep quiet. In second meeting, they feel, okay, I'll greet him. And once they greet, he sees that, yeah, his gesture is good. He is responding. He is kind. But as they go on meeting for a month, they also understand the nature of a person, what he likes and what he don't like. And if the friendship goes for 1 year, 2 years, then gradually they understand family details, family fabric, social fabric of their connections, everything. So as the data of the user is increasing, the user is being understood more clearly, and based on proper and perfect understanding, they can really suggest him, recommend him, and do their advertisement to the better level that will increase their business in a way. These are some of the big data customer scenarios. Anyway, you can check this in a detail level through the PPT. And coming to Hadoop, this image is very good image. This is really gives a very just in one slide. This gives the complete picture of Hadoop functionality as well. Here you can see a big file by name data. A big file, lot of information is there, and in this middle box, computer cluster, you can see that there are so many maps as well as one reduce. And as an outcome, one result file is coming. And when you compare, this is almost 1/4 time of the data file. data file, which was literally a huge file, which was given as an input to the computer cluster, and as where it was operated by the concept of map reduce, and that reduced form, which is nothing but the result, has given a very small file compared to the input. The output is very small compared to the input. So this is major concept, that the story that the computation should become easy. The very large files, very large data sets, which are not just large in their volume, but at the same time which are something which is very complex to compute as well. They have to be addressed in with this concept, what we call as map reduce, and come out with a simple result. This is the basic concept. Let us see further. And one thing to remember is Hadoop concept is purely distributed file systems. And why do we use distributed file systems? Simple, save time, save time. And here we have I have shown a simple example. I don't go in detail explanation, but you can just have a glance and understand that there is one standalone computer or one server that is doing some operation in 44 minutes. But if you take 10 in a distributed file system form, the same operation can be performed in 4.4 minutes. Here is a simple physical shown in before distributed file systems, 4 servers, 4 different locations, 4 different file systems. But when we apply DFS consolidation, we can see as we can feel as if there is only one server, and logically all file systems come under one, though they are still located in different places, but we feel as if everything is in one place. What is Hadoop? The very important and the key points to understand the concept of Hadoop is: number one, it works with large data sets. It works with large data sets. Number two, it can be operated using commodity computers. That means for this, we don't require any sophisticated, huge setup. Your laptop, my laptop, our neighbor's laptop can be connected in the cluster of Hadoop. Commodity machines can be connected. And the third point is, programming part is very simple. We need to just perform the write the map code and execute. And all these companies listed below are using these concepts. What are the benefits? Benefits, as we are using commodity hardware, obviously commodity hardware is not that reliable, but still we are getting reliable solutions. We are designed for large data files or data sets. And likewise, first the data is loaded, then it is structured, designed to maximum throughput. Performance is increased, parallelism is increased, scalability is possible, flexibility is high. All these benefits are related with Hadoop. Core components of Hadoop. First is MapReduce, which is used for computational part, and second is HDFS, that is used for storage. As we go further, we see all details related to these two terms. In network topologies, we can see so many shared memory concept is there, peer-to-peer is there, ring topology is there, likewise master-slave topology is also there. Like For Hadoop architecture, we follow the master-slave topology, master-slave architecture. Here you can see that as per the diagram, you can understand the above part is related with map reduce layer, where task, where there is a job tracker, and that job tracker keep track of task trackers. And HDFS layer, the lower, it has two components. One as name node and another is the data node. Name node keeps the whole details of the data node. That is just shown pictorially. Map, master, and source. Here is the example. All the job tracker is keeping track of all the task trackers, and name node is keeping track of all the data nodes. What is HDFS? Hadoop distributed file system. First thing is it is highly fault tolerant. Why it is highly fault tolerant? Because as we are using commodity hardware, we save data in replicated form. Like every logical block of data is being stored in 3 different locations, because the commodity hardware may collapse at any time. So if one hardware collapse, then there will be two more copies. So with that level of activity, this architecture is highly fault tolerant. Generally, it never comes in a situation. Generally, the situation never comes where all 3 copies got crushed. And high throughput, the performance also increases, and the suitable for applications with large data sets. The Hadoop is meant for large data sets. It is not good for small data sets. And why we shall be discussing later. Because when we are in a short, if I say, when the data is being split into logical modules and being stored at various machines, then the data node, which is responsible for tracking all, sorry, the name node, which is responsible for tracking all data nodes, will be having the details. And if the file modules are very small and very short, then the metadata itself will become so huge that it will not be advisable to have small data sets. It's always better to have large data sets, and we work with that. Can be built on commodity hardware. As it is explained, we don't require hi-fi infrastructure. Simple infrastructure is also enough to run the Hadoops. And in situations where it is not good, where there is low latency, it's not advisable. Lots of small files are there, it's not advisable. In situations where multiple writes, arbitrary file modifications are there, it is not advisable. Let's see with a small, let's try to understand with this small, with this slide, that name node and data node. For name node, you can see I have kept an image of Lamborghini. The reason is Lamborghini is a very reliable and 100% trusted, and it never break down. And data nodes, I have kept the taxis, because taxis will serve in a very wonderful level to maximum people range, and out of 100 trips, maybe one time it may fail as well, but 99 trips it do works well. So because if a data node fail, there is not big loss. The data packets are logical blocks of data stored on a particular hardware, can be retrieved from other two. But for name node, which is responsible not only having metadata of every data node, but at the same time, if it is only one, so if this collapse, then the whole architecture comes to a break. So in that particular situation, one thing which is very important to maintain is data node, name node, that is with high configured and reliable machine, so that its reliability is high and it continues working for a longer period without interrupting the functionality of Hadoop. Coming to the architecture explanation, client and job tracker and task tracker. Client is in a simple form, if I say, client is uh, an application that interact with the name node as well as the data node. And as we have seen in earlier images, job tracker is located in the name node, and the task trackers are located in the data nodes. So client is an application which will interact or which will coordinate, which will interact with the job tracker as well as the task trackers. And coming to HDFS architecture, here you can see some of the terms. If I explain the terminology, I think you can understand the uh, whole concept of it. As I told you, name node will keep track of the details of data nodes. So name node is one and data nodes are many, and all those data node details are in name node, and in name node there is a metadata. What is metadata? Metadata is data about the data, like which logical block is located in which place, what extension, and all the things related with that block is in the metadata, and that is residing in name node. Another part you can see rack. Rack is a something like shelf where storage devices are placed, and replication. I have just explained you that because we are using commodity hardware, every data module is being block is being stored in three different locations or three different machines, so that if one fails, the other two will support. So in that particular situation, we need to have replications. That is what is shown here. Job tracker. Here you can see one more new term as user. User is something like you and me. Whenever we want to communicate with the client, the application which interacts with the job tracker as well as task tracker, we just get we copy the input files from the DFS, and whatever, if we want to customize or make some changes, then we do that and submit the job to the client. Then the client pulls the supporting files from the DFS, then splits that into modules. As I told you earlier also, huge files are taken as input. Then those huge files are split into logical blocks, and each block is assigned to each machine. And when computation is done, they are done at their particular locations, and they are reduced and brought to one point, and the results are checked. So this is how the user gives an input. Then client takes the supporting files, breaks it into splits it, and assigns to the job tracker. And what does job tracker do later? The job tracker receives the job, then that initiates the job by putting those in the job queue, and based on the numbering sequence, they are given as to the situation where maps and reducers are working. And one thing to remember, as many maps, as many splits are there. That means if in a large program 100 splits are made, then we need to offer 100 maps on that. Every map will perform computation on each split. So though as many maps are there, so as many splits are there, those many maps are given. And based on the output provided, reducers will reduce and give the output in a reduced form. So many splits are there, so many maps are offered, and reducers are only 4. Likewise, even in the first image I have shown, the data file which is being given as input is very large, but in the computer clusters, the modules are how many modules are there? So many maps are there, and reducer works on in the end and offers the result file, which is almost very compared to the input compares to the input file. So this is how the job tracker works. Then coming to the job tracker functionality, like how do it understand which hardware is working fine? And here we again see that there is a concept of heartbeat. Every machine sends a signal to the job tracker that it's fine, and it can be assigned some task, and this goes on whichever is live, whichever is active, whichever is ready to receive data. Based on the requirement and situation, job tracker will be offering and assigning the task. This is how it goes on. And here how it works, like the data is the user gives some assignment, then the data is being passed to the data nodes, and in a more clear and in a more easy and simple manner, it is also as shown ahead. And something, this is file writing anatomy, and this is read, how it reads anatomy. In file writing anatomy, you can see that it's going in a sequential form. First, create command is being given, then the name node creates, then write is being performed. When the write is being performed, then the written packet is carried to data node 1, then it is being passed to data node 2, then it is being passed to data node 3, and later fifth point is going with the acknowledge packet that it has received. When the acknowledge is received, it is closed, and it is completely, the operation is closed. Here something to concentrate is, when we are storing, it is going in a sequential form, but when we are reading, it is being read parallelly from all 3 locations or 2 locations. It will, wherever the data is there, it reads in a parallel form, just to increase the performance. How the data is being stored in racks? There are 3 racks, that is rack 1, 2, 3, and there are 3 blocks, block A, B, C, and block A is stored in rack 1, likewise 2 in rack 2, then B is placed 1 copy in rack 2, another 2 copies in rack 3, sometime and third block C in rack 3, then 2 in rack 1. But it does not mean, in this image you can see that 1 copy is in 1 machine and other 2 copies are placed in the other rack. It does not mean that every operation will be like first rack 1 copy and other rack 2 copies. No, it can it is just accidentally shown in this example, but it can go 3 copies in 3 different racks as well. And remember these 3 different racks. And here, for more clarity of understanding what are maps and how they perform operations. I know you people are listening, but the thing is, you may be little confused, like what actually map is and how does map work. So map is simply a logic which performs computations, and we write a code. And something you need to understand here is the very important concept of Hadoop. That is, the Hadoop has the beauty, a special beauty, or a special qualification, or a special feature, or a special thing which makes it outstanding compared to others. That is a data localization. This term is very important. I did not write this term in the slide, but listen very carefully. Data localization is the main concept which makes Hadoop different with all other architectures. What is data localization? To understand data localization, something like, for example, in normal scenarios, in normal scenarios, the data is, excuse me, in normal scenarios, the data is stored in a calculated amounts, or in a calculated amount. But in big data problems, the data is voluminous, and in that particular situation, when we want to compute anything, when we want to compute any file, then the huge then the hu- then the huge data cannot be brought to the server, computing server, and perform the operations. Instead of that, this map is a small program which contains some MB of capacity. That that MB of capacity program is sent to all servers. Instead of taking the data from server and computing and sending it back, then huge congestion in the network. If we start taking data from the servers, like some petabytes of data is available on each server, and to perform an operation, we want to have the data from 4 servers, and we pull the 4 server data to one place for computing. Then if we want to pull it and bring everything, and if the data start traveling from one point to another point for computation, then again after computation we send it back, and again it in the server, it is not possible. It is not possible. Huge congestion takes place. So to solve this problem, the best feature come is data localization. In data localization, the data will be in its local place. The data will be in, and the map will travel to the location where the data is stored. And this is how this happens. You can just see this. There are 4 servers and one map code. And this, when we want to perform, when we are performing operations, we just take the code. As I told you, we don't pull the required data from various locations and start performing computations. Instead of that, data is in their local places, but the map code travels to all the servers. This is what happens. This map code is sent to all servers, and this will and perform the mapping operation over there. Now the point comes, what is mapping operation? There is a very good example I had. I will be showing you, don't worry. But here something to understand is data localization. Data is residing in their local devices. Only the map code is traveling to them and performing mapping operation. And after reducing, we get the result. Fine. Actually, this meeting got delayed to start, and I am having some other engagements. That's why my dad is calling so frequently. He is waiting for me to arrive there. I'll try to pack it as early as possible. 3 examples are shown here, but I am taking the one which is most simple and very easy to understand. And I'm not explaining the other 2 because we are already getting short of time, and people are waiting for me. Um, so just concentrate on this example. Here is a input file with this data. Then in this, we are in second stage, we are splitting. That is line 1 in one mode, in one block, and line 2 in another block, and in line 3 another block. Here, after bringing 3 modules at 3 by splitting at 3 level, here we are mapping. What is that we are mapping? We are saying that deer has come one time, beer has come one time, river has come one time, car has come one time, and another car that is one time, and river has come another time. One more time. Sorry, one time. I'm getting so many calls. You can see the screen. You can see my screen. So anyway, I'll try to wind up. Then again, in this block, again these 3 have come one time. So now when we shuffle, we see that in all these 3 mapped locations, bear has come in 2 places, car has come in 3 places, and deer has come in 2 places, and river has come in 2 places. Then we reduce it. How do we reduce? Bear has come in 2 places, car has come in 3 places, deer has come in 2 places, and river has come in 2 places. Ultimately, the reduced list is this. So this example is very small. Looking at this, you may feel that the change is not that significant. It is not reduced so much. But instead of this 2 small files, this small file is taking only for simplicity in understanding. But imagine that here you have at the input point, you have a text of almost 1000 pages of PDF. And then what will be the output? The reduced part will not be more than 10 pages. Just tentative I am speaking. So this is how the reduced part takes place. And these are the steps. Input is there, splitting is there, mapping is there, shuffling is there, reducing is there, and final result is there. So you can see splitting, how the mapping is taking place, and how shuffling step works, and how the reduce, and how the final results. Fine. Then another example, similar, you can just have a look. You will understand later. Anyway, the PPT is given to the organizers. Then here, there are some of the future opportunities. The opportunities are very high. You have plenty of opportunities in Hadoop in this. And this is what is the demand and supply. The demand is more than what is being supplied. So if anybody wants to make the career in Hadoop, the jobs are waiting, opportunities are waiting, and really you have a very big market to perform and prove yourself and have a good career in that. Here I would like to stop. Thank you for this opportunity, and thank you for peaceful listening and patiently listening.
Thank you, sir.
Welcome.
Next is open session. You may ask question to the resource person and clear the doubts. I think no one has doubts. So I request Mrs. Howlett, Assistant Professor, to propose a vote of thanks.
It has been great pleasure to host a webinar on big data using Hadoop. I extend my gratitude towards the speaker, Dr. Mohammed Abdul Hamid, Assistant Professor, Osmania University. Thank you, sir. I am very grateful to our principal, Dr. Ayub K, for being strong support and inspiration. Thank you, sir. I must thank Professor Riyad A.M., HOD Computer Science, and Dr. Jamshila, Associate Professor Computer Science, who worked hard to make this program a grand success. Last but not least, a big thanks to all my colleagues, all participants, technical assistants, and my dear students for the smooth functioning of the program. Thank you all. Thank you once again.
Thank you, Havlat. I think it's time for winding up. Thank you, Hamid sir. It was an informative session. Thank you all.